Fantastic. Well, welcome, folks, to the third session of today's Launch in the LF-Edge End User Community workshop. For those that were unable to attend the overview or oil and gas sessions earlier, those sessions will be made available via the SwapCard platform and also the LF-Edge YouTube channel shortly. In this session, we welcome Benoit from RTE to provide a use case on energy. Benoit, I'll let you further introduce and take it away from here.
Okay, thank you very much. Thank you very much for the invitation. I'm very happy to be with you tonight for me and this morning for you probably. So I work for RTE and as an architect. Sorry, I cannot change my screen. What? Okay. So I work for RTE as an architect, and my main mission in RTE is actually to support the various projects that are intending to work with our open source tools, and especially if they want to be involved in communities and build new use case based on open source project. A few words about RTE. So RTE operates, maintains, and develops the French electricity transmission network. So we own 106 plus kilometers of power lines. So a few figures. There is a power supply continuity that is at a very high level. We're nearly 9,000 employers, 4.8 million euros, billion euros sales in 2019. We invest largely in the R&D with 35 million euro per year. And our customer are saying that they are satisfied with the quality of what we deliver them. RTE operates means that we're in real time operating the power system. So that's much more than the grid. This means that we have to take care of the balancing, so ensuring that the consumption and the generation are at the same level to be balanced. We maintain the network. We are actually the owner of the network, and so we invest on it by the developments, the renewal also, and we maintain it, meaning that the team that you can see on the tower in the picture are people that are working directly for RTE. And that's important for us also to have, so we have mainly two technical business that are so a real-time operation on one side and asset management on the other side. And both of them require us to have a good understanding of what happened in the edge of our network, the physical network. As I told you, I work in RTE for the open source, and that was a choice that we made about 2 years ago, and decided to be more volunteering for open source, following the open source trend, and being more active and actors of in the open source field. Why did we did this move? First, it's because we tried. We have a long story of R&D in RTE and in EDF beforehand, and we developed a lot of software on our own. And we are facing with the energy transition a wall of development, and we will never be able to cover all our needs. And our first thought was that we would be able to sell our own solution to others to be able to finance the development of the new one. That was a bad move. And actually, now we think that it's better for us to support communities, to be involved in communities, to lead actually some communities on tools that are strategic for us, and to be able to have software that are no vendor lock. We need also to have white boxes. We take a lot of decisions based on the algorithms, and we want to be able to understand the heart of the algorithms. And we would like also to be able to support on our own the most of the core software that we use for our business. So we were very active in the Linux Foundation Energy, and we're a premium member of the Linux Foundation Energy since the very beginning. So that's we are cousin of the Linux Foundation Edge. And we gave to the community two pieces of software that are Possible and Operator Fabric. Possible is a library that is used to build study tools to be able to simulate the behavior of a power system. So Possible for power system block. And Operator Fabric is a framework that is designed for the real-time operator, so the people that are in the control room and that are monitoring the power system and taking the real-time decision that are required for the grid to be sustained in a secure manner. So the use case that I will develop today and we are concerned with is related, of course, to data exchange. Actually, that's always the what we are dealing with when we're discussing about software. And today, so what you can see in the picture on top left is a dispatching. That's not dispatching from RTE, a control room. And actually, from the control room, we are able to monitor all the grid elements that we operate, and so monitor their actual state. And but from the power system perspective, so that's only the information that are needed for us to take the right decision regarding the power system. So meaning that we are looking for being able to understand the flow that are on the wires, the voltage, the frequency, and the topology of the grid, meaning the position of each switch in each substation. So we have today 2,400 plus substation in which we have a lot of devices that are connected and that we gather in some control rooms, but in the near future, this will be handled by only one single SCADA, and that will be displayed in 3 control rooms. Today we have 8 control rooms, but tomorrow we'll have 3 of them that will gather all that data for the operators. And we also control the devices. So that's mainly tap position for the transformer, and that's the switch position, so open, close, and that's some threshold that are to be operated mainly for the voltage control. In the future, we'll have to gather far more data at the central level from the field to because assets are getting old, they are aging, and so looking for the asset management, we need to have a better understanding of their health and monitor the asset for themselves, not only monitoring their function, but monitoring how they work, just to be able to assess whether they're in good shape or if we need to do special maintenance on it. So we will deploy a lot more IoT and a lot more sensors, and we will have a lot more data to be managed. And probably the edge computing will be absolutely needed, because we will gather a lot more data. And we need to be able to analyze these data directly at the substation level, just to before sending them at the centralized level. But that's not today's use case, because we're just doing today a baby step. But we need to have that in mind when we are discussing on asset monitoring. One use case that will not be developed today, but I can tell you a bit of it, is if we record the waveform of the grid. So in France, that's 50 Hertz. Actually, in Europe, we are at 50 Hertz. So if we record the wave in each wire for the voltage and the current, there is a lot of information in the wave on what happened in the wires directly. So that's a huge amount of data. And if we are able to have algorithm on the edge just to give the piece of information that is required for us to understand the state of the assets, that would be very useful. But that's not for today's use case. Today's use case is far more simple, but actually, I'm very happy to have lots of support from the Fledge community. Today's use case is just based on our telecontrol architecture. And what we want to be able is actually to connect the devices that are on the field toward a bunch of application of apps that are at the centralized level. One key app is the SCADA. The SCADA, so that enables the operator, as you can see on the picture, to see the state of the grid. And between the RTU that are the devices that are very close to the edge, so that the RTU are connected to the physical assets, meaning the switch or the sensors. There is a string of devices and protocols connecting them from the RTU to the SCADA or other centralized application. So there are low-level protocols, and on that picture you could see, for example, the IEC 104. That is not the lowest one, but that's one of the low-level protocol. And the SCADA will consume in the future the OPCUA protocol. And actually, we have a lot of different combination of protocol conversion. So the next slide will show you the difference between the edge protocols on one hand and the data center protocol. Very quickly, I don't want to talk of RTE and EDF, H and Z, that are H and Z. Both protocol are legacy protocol, homemade, designed by EDF. We will no longer use other, but H and Z is still will still be implemented for a while, because we have lots of assets that are directly connected in H and Z. The choice was made to use the IEC 104 for connecting the substation to the various centers. I don't know why it was IAC. It's a pretty low-level protocol, so that is able to gather the data from directly the equipment through the RTU to the centralized level. 61850 is a new protocol for us. It's far more verbose. You have a lot of information. You have an object modeling embedded with it. It's a very modern protocol that enables to have lots of functionality directly at the substation level. We are at the beginning of the story for the 61HCC, but you know, we have such legacy and the number of substations is so big that we will keep the old protocol for decades probably. So we are only at the beginning for the 61850, but we need to be able to consume this protocol as well as the HNZ and IEC 104. And the actual protocol we have at the data center level is the TASE2. And we are moving progressive step by step toward the OPCUA, but the TASE2 will still be needed for special communication, especially to communicate with other TSOs in Europe. So the next picture will show you different combination of conversion that we may have. What we call the MPG is a multi-protocol gateway, and so you can see that we will need to implement it in various levels. So with various feature, actually, this can be in the field, so in the substation, and converting only 61850 to 104, or it can be at the centralized level and be able to receive data from many substations and convert them from 104 to TASE2 or OPCUA. And actually, I'm not sure that we display in that slide all the combinations that would be required. So when you see substation in the bottom, it's 2,400 plus substations, you know, so that's there will be a lot of MPG on field, multi-protocol gateway on field, and at the centralized level, we will have mainly 2 sites, but for the transition period, we have 75 sites that will be communication nodes in which we will need to have protocol gateways. And on top, you have in the data center the various applications. So you have, of course, the SCADA, but you have also a tool that we are developing with the Plasma project. That's just to another generation of asset monitoring, in which we will be able also to gather far more information than the one we are gathering with the SCADA, and so that's for the asset management. And we have also some automation that may be implemented at various levels. So it may be at the data center level, or it will also at the substation level to be able to control the behavior of the grid based on various events that could occur at close to the edge, actually. So as you could see, what we're expecting from that project of the protocol gateway is to be able to have something that may have a different shape, something that is flexible enough to be able to be embedded in a very small computer at the edge level, and also being able to use that same software at the centralized level, just changing the configuration or and maybe the infrastructure architecture around it. But what we expect for performance requirements, so that's mainly in case of cascading effects, also these kind of events in which we need to have a full system that is responding to big events. We need to be able for one gateway to send 500 controls per second and 500 set points per second, and to receive 1500 measurements every 10 seconds and 3400 status per second. So that's for the operational needs are these requirements. So that's just for controlling the grid, not for the asset management. Yes, the information that we are gathering from the field, and the control that are pretty simple actually. The measurements we have are for each line and node in the grid, the voltage, the current, and we translate that into power, active and reactive power, and we need also to be able to have the state of the switch and of the substations and being able to control them. So what are the expectations of the project? Just for the time being, we already have protocol gateways. They are all proprietary. Or we developed some. So we bought some of them are proprietary but specific to RTE. What we intend to have is mainly to rationalize the future deployed gateway system. We'd like to have one single or not more than two kind of technologies for the gateway system. We need also to be able to ready for adaptability. And as you know, the power system is evolving a lot. You know, there will be electrical vehicle in the near future. The storage is so the energy transition is changing also the way we will operate the system, and it's very fast moving. So we will probably have a new use case more than the protocol conversion to be applied. And for us, that's interesting. So the next slide will be related to Fledge, because actually that's the solution we'd like to test and probably to implement. The protocol gateway is a baby step, but it's a first step toward the use of edge component, and probably Fledge have the right skills for us to right feature for us to do what we need for the multi-protocol gateway, and for the future use case we do not know yet. So here are some requirements that we need to address for the multi-protocol gateway. So that's security. That's very, very important. You know, that's very strategic for a country to have a secure power system, and the security of the power system rely on the IT that enables to monitor and control it. Then we need also to have an architecture that is scalable, because we would like to be able to implement the protocol gateway at various level, and scalability would offer us the ability to to handle big amount of data and having the high, keeping the high availability. So the performances, we already discussed it, but that's the performances for the first version of the use of this edge component and modularity. And that's probably, and that's very, very important, the modularity, to be able to have the various kind of algorithm. And actually, that's what seduced us when we looked at Fledge, was its modularity, the ability for us to have plugins at in the north, south, and also in the core layers of the architecture. And that's natural in the architecture of Fledge. So just to go back to the story of why we're using Fledge. First, so the idea of doing this multiple gateway as an open source project. So I called a few people, and Daniel from OSI Soft told me, you should, for your use case, use Fledge. That's an interesting project for you. That was a good idea. And we decided to make a proof of concept, and it was very easy for us to implement the IEC 104 protocol in the South plugin. We contract that with just students that could do that in a few weeks. So it was very simple. And we want to extend our proof of concept by implementing the 61850 protocol. This will be done by the same students, but this will be found by another transmission system operator, Swissgrid, that wants to be part of this adventure and understood that Fledge could be a good solution for this. For this kind of use cases. So we're open for partners to discuss this use case and to extend it to other needs in the power area. I think the time is running very fast. So how does Fledge meet our requirements? So Fledge is based on microservice architecture, so it's modular by design, and it's very easy for us to change to implement various plugins. So that can cover a huge numbers of use cases. And it's not a monolith. You can have a very lightweight solution at the edge. So it will be important for us when it will be in the substation. Scalable, high availability is taken into account, but we need to still test it in our context. What else? Fledge is an open source project backed up by serious company, and for us to see that OSI Soft and Dynamics are behind that project. That's something that that give us trust in the project. And as it is an open source project, we can also invest on internal skills on people that could be able to work directly in the code of Fledge. And we think that Fledge has the potential to cover use cases that we did not even think of yet, and it's worth really looking at it closely. Thank you for your attention. If you have any question.
Yeah, and thank you, Benoit. Unfortunately, we don't have much time for questions as we've reached the end of the time slot. But certainly, if there are questions, please do direct those to info@LFEdge. We'll make sure we put you in touch with Benoit. Up next, we have another energy use case with Jacksonville Energy Authority, who will be presenting on their work with Fledge as well. So for those on the line that are interested in joining that session, please disconnect, rejoin via the swap card platform. There will be a separate link. And then if you didn't catch it at the beginning, we are recording each of these. So if you'd like to revisit this session as well, it will be posted both on Swapcard and the LFEdge YouTube shortly thereafter. So thank you again, Benoit, and thanks all for dialing in. We'll see you on the next one.